So I guess I'm doing the introduction. Um, Welcome to a very frigid edition of the second Saturday Stars at the McCarthy Observatory. This month is going to be a rescheduling of last month's presentation given by Kyle Cloutier, who works for the Jet Propulsion Lab over in California. So this is a very special presentation on the Cassini spacecraft from somebody who has spent a good amount of time actually operating the spacecraft itself. So this is a very special treat. So I'm really looking forward to this, and hope all of you are as well. So take it away, Kyle.
All right, thanks, Mark. So hi, everyone. My name is Kyle Cloutier. I'm currently a mission operations engineer at NASA's Jet Propulsion Laboratory out in Pasadena, California, where I won't tell you what temperature it is here because I don't think you would appreciate it. But today we're here to talk about the Cassini spacecraft, which until recently was studying the planet Saturn and its atmosphere, its rings, and its 62 moons. In this picture here, you can see it's in one of our test facilities before launch. You can see the people in the bottom of the picture here, if I can find my mouse. So you can see that with the people here, that the spacecraft is huge. It's 22 feet tall, 13 feet in diameter. It had 12 instruments on board. It also has the Huygens space probe attached to it, which was provided to us by the European Space Agency. Cassini was actually a mission that collaborated with over 26 nations. So it was a mission that was very globally collaborated with. Altogether, with the probe and fully fueled, this spacecraft weighed over 12,000 pounds. So she was pretty big. A brief history of Cassini's mission. We launched in 1997, which was before I worked here. In order to get to Saturn, we used gravity assist from other planets in the solar system. We flew by Venus twice, and then flew by Earth, through the asteroid belt, past Jupiter, and arrived at Saturn in 2004. And before we were even in a stable orbit around the planet, Cassini had already discovered 2 new moons, Methone and Pallene. And I mention that because it's a great example of why we should be sending these spacecraft into the solar system to explore. Being there up close, it makes all the difference. So we arrived in 2004. Our prime mission was 4 years long. We then requested an extension through the Equinox mission. The prime mission we arrived at was during sorry about that. We arrived at during the winter solstice of Saturn. It was the Saturn year is 29 years long, not 29 Earth years long. So that's how long it takes Saturn to go around the sun. So we arrived in the winter solstice for the northern hemisphere. In 2009, the spring equinox, we were there to witness. And then in 2010, we extended our mission further to get us through the summer solstice. So in total, we were at Saturn for 13 years, which is about half of a Saturnian year. By the numbers, Cassini completed over 294 orbits, flew by 162 moons. 162 flybys of the moons, took over 400,000 images, and discovered 6 new moons. Some of these moons included Enceladus and Titan, and I'll talk a little bit about those. Enceladus is a really cool moon. It's pretty tiny though. It's only 500 kilometers across. It's 10 times smaller than Titan, which is Saturn's largest moon. It's very icy, has a bright surface, very few craters, which means it's a very young surface. And when the Voyager spacecraft flew by it, the south pole of Enceladus was in darkness, so it did not see the south pole and these 4 stripes right here. Cassini saw these stripes, and these stripes are about 35 kilometers across, apart from each other. And sorry, I lost my mouse. They're 35 kilometers across and about 2 to 4 kilometers wide. They're actually, you can see that there's not a lot of craters around them, which means they're very young. The surface around them is being resurfaced very often. And in 2005, we flew by Enceladus again and noticed that with our infrared instrument that these stripes were much hotter than the rest of the ice around it. They're about 100 degrees warmer than the background ice. So this led to cryovolcanism, which essentially is cold volcanoes. Each tiger stripe is actually exuding water ice. So constant geysers spitting ice and water particles out into space. We flew by this moon multiple times, one of which was very close through the plumes and actually took samples of the particles that are coming out of these jets. Some of the things that we found inside the plumes included sodium and potassium, which basically meant that these grains and particles that were shooting out of Enceladus was basically frozen seawater. Throughout our mission, we discovered that there is actually a global ocean underneath Enceladus, and it's being heated by tectonics and the pull of Saturn. Other things that we found inside is carbon dioxide, methane, ammonia, and let's see. It's also creating its own ring around Saturn. The E-ring is being created by Enceladus. And you can see in this picture that tiny black dot in the center of the screen is actually Enceladus. The bright white below it is the jets coming out of the South Pole, and the E-ring that it's creating as it goes around Saturn. So now these jets and these are being created by hydrothermic activity is what is currently thought to be doing it. And it's heating the ice around it, melting it, and pushing it out through the vents. Now, these hydrothermal vents we think are very similar to what's on Earth, and if they are very similar to what's on Earth, that has a lot of implications for what could possibly other things that could possibly happen on Enceladus. So, for example, there could be life on Enceladus. So it's very exciting to learn that it's a very habitable environment on an icy moon this far out into the solar system. It's global, it's salty, it's been around for a long time, so there's been time for things to grow and develop inside the ocean. It's warm, and it's also giving out free samples, so we do think we're excited to go back there and look into Enceladus more. It's definitely very interesting. One of the other main moons around Saturn is actually its largest, Titan. It's 50% larger than our moon, and it's 3,000 miles across. It's about the size of the planet Mercury. And you can see in this picture, it kind of looks a little boring. It's kind of an orange ball of fuzz, but that actually means it has an atmosphere around it. And this atmosphere is about 4 times denser than the air on Earth. It's made of mostly nitrogen and methane and other hydrocarbons. Scientists believe that this moon is similar to a prehistoric Earth before life existed on Earth. Methane on Titan plays the role that water plays on Earth. It drives the weather cycle. So Titan has methane clouds, rain, rivers, lakes, and seas. When we first launched, I told you that we had the Huygens probe attached to Cassini, and the Huygens probe was released and sent down to the surface of Titan. It was the first probe to actually visit the surface of an outer planet's body. You can see as it comes through the atmosphere, it was rotating as it went through the atmosphere, but as it went down through the atmosphere, it went through the fog, through the haze, and started to get a picture of what it looked like on Titan. And you can see it kind of looks similar to Earth as far as there's mountains and there's rivers. You can see in the next picture, it's very Earth-like world. Over the course of the mission, we discovered lakes and seas. We discovered that it also has a global ocean. This lake in particular is about the size of Lake Superior. It's all made of hydrocarbons, though. It's not water. So it's all methane. So in many respects, it's an Earth-like world. It has lakes and seas. It has dunes around the equator, but it's, again, hydrocarbon dunes, not sand. So little particles of frozen methane and ethane. It has mountains, as you saw in the previous pictures, clouds made out of hydrocarbons and methane. And this picture is actually from Huygens itself. This is the dry riverbed that it landed in. Cassini also studied Saturn's rings, the crown jewel. The rings are interesting within themselves. They're a collection of icy particles. The main rings are extremely thin. However, some of the rings are quite big, thickness-wise. There's moons within the rings and pushing against the rings, so that's what creates the gaps, is the gravity dance that is occurring across the Saturnian system, pushing against ring particles and creating gaps and rings. You can see in this picture it's that the A ring is this ring right here. It's the outermost main ring. The most densest and brightest ring is the B ring. Between the A ring and the B ring is the Cassini division, which was named after the astronomer who discovered it, and it's also what our mission is named after. The C ring and the D ring in here. As I mentioned, there's also the E ring and F ring there outside of the A ring. We were lucky enough to be at Saturn during Saturn's equinox, which basically means the rings were edge-on. They were creating almost no shadow on the planet, which provided us a very unique opportunity. It only happens about once every 15 years because, as I said, a Saturnian year is 30 years long, so spring and fall equinox every 15 years. But having the rings edge-on allows you to see shadows coming from the sun, and you actually can see height of the rings and depth of the rings. So not all the rings are super thin. There's some depth here, which is very interesting. We also were able to observe the moons and tiny moonlets, and possibly observe a new moon being born. It's hard to see in this picture, but here's a zoomed in picture right here. A bunch of particles are kind of coming together and conglomerating, and particles sticking together, and possibly forming a new moon. And we think that's possibly how planets form as well. So we were very intrigued to watch this. We nicknamed it Peggy, and we watched her for a couple years, and she's still there, even though Cassini is not still there. So hopefully she'll stick around and become a new moon. We also observed Saturn's atmosphere, watched storms occur. This storm occurred at 33 degrees north latitude in 2010, and this was a ginormous storm. Storms of this magnitude on Saturn only occur once every 30 years, and this one actually happened to arrive early, so Cassini was lucky enough to catch it. This storm in this picture, you can see it actually wrapped around the entire planet. You can see it coming back in here. So we had a front row seat to observe this storm, and it circled the whole planet. Huge temperature swings, the highest measured about 80 degrees Kelvin, which is very hot. And it was kicking up particles into the atmosphere that we'd never detected before. It eventually came back around again and died down. But it was an amazing thing to see this weather pattern happen on another planet. Here it is in false color. It almost brings out the detail even more. And then in infrared, you can see that the temperature is much higher in the storm than the rest of the planet. Up in the North Pole, we also have the hexagonal jet stream, which I think is fascinating and beautiful. The jet stream was observed by Voyager 35 years ago, and it's still there today. And we did our best to observe it as best we could. We still don't know what's driving it, but essentially the jet stream is pushing itself around in a hexagonal way. It's about the size of 2 Earth diameters, and the winds are blowing about winds are blowing at about 320 kilometers per second. So we've never seen weather like this before in the solar system. And the vortices themselves are whipping it into this hexagonal shape. In the center right here is actually a hurricane. This hurricane is actually 50 times bigger than any Earth hurricane and 4 times faster. It's about 2,000 kilometers across. So over the 13 years that we were at Saturn, this is our full tour, essentially every orbit we did around Saturn. We did our best to look at Saturn and the planet from every angle that we possibly could. Saturn is this tiny dot in the middle. I'll just take out everything except the last 7 years of our orbit. This is the Solstice mission in gray. So the most recent 7 years from 2010 to 2017. We did not extend our mission after 2017 because we were actually out of fuel, and there's no gas stations at Saturn. So we had to end our mission in 2017. So at the end of November of 2016, we started with our ring-grazing orbits, which are shown here in white. These took us just outside the F ring in 20 different dives, and it got us up close and personal with a lot of the moons. And then in April 2017, we started our grand finale, which are shown in blue here. This consisted of 22 dives through the gap between the planet and its rings. So we can just zoom in here. Again, the white orbits are just outside the F ring, and the blue orbits are just inside all of the rings and between the rings and the planet itself. The orange orbit you see here is our very final orbit that sends us into the atmosphere of the planet. So now, why did we want to do this? So we were out of gas, like I said, out of fuel. And there's a rule about planetary protection. As I mentioned, Saturn has multiple ocean worlds surrounding it, Enceladus, Titan, and possibly others. So we wanted to protect them. We didn't want to contaminate them with all of our germs and all of our radiation. So we had to dispose of Cassini in a safe way. And the best way we knew how to do that was to crash it into Saturn, which would essentially tear it up and protect the moons surrounding Saturn. We also really wanted to do it this way because we get really unique science by going in between the planet and the rings itself. That included Saturn's internal structure. We'd learn about the gravitational and the magnetic field. We learned the mass of the rings, which after being there for 13 years, we still did not know how old the rings are, and the mass can help you determine how old the rings are. We wanted to study the ionosphere, the radiation of Saturn, and different particles of the rings. We got our highest resolution pictures of the rings using radar and imaging. We also could sample directly into the atmosphere and the ring particles, which obviously had never been done before. We also got really up close to that hexagon that I showed you, and the polar hurricane, and the aurora. So just like Earth has an aurora, Saturn also has a beautiful aurora, and we wanted to see that up close. So in order to plan that, though, we had to dive between the rings and the planet, and this is probably one of our best pictures of what is going on between that gap. So we didn't really know what was between the gap in the rings and the planet, and we were a little worried if the particles extended all the way to the planet or if it was actually empty space. So it was a dangerous mission, but we were willing to risk it for that incredible science. So here are our 22 orbits in between the rings and the planet, with orange being the last dive into the atmosphere. So we had 22 ring plane crossings which is probably the most dangerous part of it. We were hitting particles left and right. We didn't know how much debris would be in between. And here are our periapses, which would be the closest we ever got to the planet, and the atmosphere is where we would, and these 5 down here would actually be where we'd be sampling the atmosphere. So these orbits took us a long time to plan. We were going at different altitudes, the purple being the ring plane crossing altitude, and the green being the periaps altitude. At a certain point, we were a little worried about where the atmosphere started and whether it would pull us in too early. So we did have to be prepared to either change our orbit to come outside of the atmosphere, or move closer if we weren't close enough. And this is a depiction of what it actually looked like for the spacecraft to dive in between the rings. So like I said, on November 30th, we started our ring grazing orbits, and they were just outside the F-ring. In April, we started our grand finale with our last flyby of Titan. You can see it depicting here. We used Titan throughout the mission to change our orbits, and that's how we got that crazy spaghetti orbit that I showed you in one of the earlier slides. And you can see here, on April 22nd, here's Titan coming in, and we change our orbit. Now we're in the blue orbit, and we start to dive in between the rings and the planet. So that's kicked off our 22.5 orbits, and I say a half because on our last orbit, we didn't complete it. We ended up in the planet. Our first dive was April 26th. April 26th was our first dive. And on September 11th, we had one last non-targeted flyby of Titan, which gave us our kiss goodbye into the planet. And that was a ballistic trajectory. As soon as we passed Titan, there was no going back. And we impacted at 4:55 a.m. on September 15th. So throughout this mission, we gathered tons of gigabits of data, and even though our mission ended in September, there's still massive amounts of data to be analyzed, and it will be for years to come. We got so much surprising and exciting data. Scientists are trying to figure out what it all means and the answers to the questions we talked about earlier. So keep an eye out in the news. I've seen some theories and publications. But I think the main thing we learned about Cassini in our 13 years at Saturn is that there's still so much to explore, and we have to go back. So are there any questions? I'm not a scientist, however, I will do my best to answer the science questions.
I have one. Is there anything beyond Saturn, or you don't know that yet?
I'm sorry, I'm having a little bit of trouble hearing.
Is there anything beyond Saturn, or you haven't gotten that far yet? Do you know if anything's beyond?
Other missions beyond Saturn?
Well, I mean, do you know just by studying this planet, is there anything beyond that, or you don't know yet?
Other planets?
Yeah, other planets?
Yep, so Uranus and Neptune are out further than Saturn. We don't currently have any missions planned to go there, though they're definitely intriguing. One of our options, instead of doing the dives between the planets, was to actually head out towards those planets. But we currently do not have any missions at Neptune or Uranus at the moment. Pluto, which is not currently a planet anymore, is being, or actually was a year ago, visited by the spacecraft New Horizons. it did a flyby. Those pictures are fantastic. I think it's now on its way to a Kuiper Belt object.
You say Titan is methane. Is that methane flammable, like methane is here?
Yeah, a lot of it's frozen.
Uh-huh.
Some of it's liquid. But it provides a really interesting thought process of, the life cycle on Earth here is dependent on water. What kind of life cycle on Titan could be dependent on methane? So it wouldn't be life as we know it, but it might be life based on methane, which would be really interesting.
I have something to share.
Yes.
Some scientists think there actually is life in the methane on Titan, but what they think though is that there are some yard-long bag-like organisms swimming in the methane lakes and feeding off the methane.
Yeah, it's definitely possible that that life could be based on methane and on Titan. We'll have to do another mission to go to Titan and explore it even further.
Yeah, but this time they think that instead of evolving from microscopic organisms, they jumped all the way to big things.
Oh.
If you watch the Saturn edition of the planets to learn more.
Okay,
What's
thanks.
so funny, guys? What's so funny, guys?
Very well informed. Yes. We're impressed.
So, what's the next mission plan to Saturn or Titan?
Yeah, currently no mission is planned for Saturn or Titan or Enceladus, which is too bad. I would encourage you guys to write to your congressman if you guys think it's worth going back. There was a series of proposals out there to visit the Saturnian system again. However, none of them were chosen. We do currently have a mission to Jupiter's moon, Europa, which also has a global ocean. So that should be interesting.
It's because I got the idea because I've heard about, like, the New Frontiers program. And, like, one of the finalists was, like, a mission to Titan.
Yeah, you're absolutely right. Unfortunately, that was not chosen, which is too bad. I was very sad about that.
The website on the screen, does it have any pictures of the approach and impact?
Yes, it does. In the last several hours, however, we did take a picture of our impact site before we went in. We did not take pictures as we were going in. We dedicated all that time to the particle instruments, to take the particles and analyze them as we went in. We also turned back to Earth to stream that data live as we were going in, which faced the cameras outward. So we don't have pictures going in, but we do have pictures right before impact. Yeah, and I would encourage you guys to visit the site and look at all the pictures that the Cassini took over the lifetime of its mission.
So what was your role as part of the mission?
Was the question, what was my role?
Yeah, as part of the mission.
Yeah, my role was to work as a science planning integrator. So I was lucky enough to work with all the scientists and incorporate their science observations into the mission. So basically, if they told me that they wanted to take a certain type of observation, we would build the commands of the spacecraft to actually execute them. And it was kind of an intricate dance to operate the spacecraft. All of the instruments were hard mounted on the spacecraft. So in order to use one instrument and then use another, you had to actually physically rotate the entire spacecraft. So it was constantly flipping around and rotating to get all the great science data. So that in itself was a whole job.
Very cool.
And what are you doing now, Kyle?
Yeah, so now that the Cassini mission has ended, I've moved on to the InSight project. InSight is a lander that's launching to Mars in May. That's scheduled to land on Mars in November around Thanksgiving, and that will be in the internal structure of Mars and looking for Mars quakes and seeing if the internal structure of Mars is still active.
Does it have a bore on it?
Sorry?
Is it a lander?
Yes, it's a lander.
Does it have a boring tool?
Yep, it'll have a hammer. That's also a collaborative project. The German Space Agency provided a hammer that will hammer into the ground and take internal temperature measurements. It'll also have one of the most delicate and precise seismometers to measure the tremors of Mars, if there are any. And that instrument is very interesting. It's currently sitting in Denver, and it can feel the waves hitting the ocean on the beach in Los Angeles. So it can feel precise measurements.
Does that spacecraft have cameras on it that like take pictures of Mars' surface?
Yep, it will.
Kyle?
Yep.
We have a question via text messaging from Connor, whose question is, if the South Pole ejections from Enceladus created a ring, how were the other rings created?
That's a good question. We don't actually know the answer to that. Could be in a variety of ways. Since Saturn is so big, it could be pulling particles in from around the solar system. We don't actually know how Saturn is replenishing its system, and we don't know how old these rings are, if these particles are going to stay in the rings or if they're slowly being pulled into Saturn. So that was one of the main reasons to dive in between the rings and the planet itself, is to learn more about how these rings are hanging out there, and if they're changing, if they're growing, if they're shrinking. So no, we don't actually know where these particles are coming from, possibly all around the solar system a long time ago.
Do you know if the rings are tidally locked? So, like, do they match the rotation of Saturn?
Yeah, they actually do. And it's interesting, there's a lot of, as I said before, it's kind of a dance of gravity. And each ring particle is essentially pulling on the other ring particles, and bigger ring particles have more of a pull. So that's how the gaps in the rings are created, and that's how the moons are created. But they are locked, essentially.
Kyle, for the young people in the audience, can you tell us a little bit about yourself in terms of what your education was and how old you are now and how you got to where you're at?
Maybe not the how old you are now.
Sure, yeah. I actually am from New Milford. I went to New Milford High School. And I really liked math and science, so I decided to become an engineer. And I really liked astronomy from volunteering at the observatory here. So I chose aerospace engineering, and I wanted to learn more about the planets and space. So when I graduated college, I applied for a job at NASA, and was lucky enough to receive a job, and I've been working here for almost 4 years now.
I have a question. Did you have to go for your master's, or did you just go?
No, I don't have a master's actually.
No.
And that's one of the rare fields that you don't actually need a higher degree, which is kind of nice. I am working on a master's right now, but it was not required for my job.
All right, any last minute questions, or can we get some more people in out of the cold?
Yeah. Thank you.
Thank you.
Thank you, guys.